Recall that we were talking about different kind of sensation of texture. And we mentioned that, in fact, we can also feel pain. Pain is felt by this kind of receptor called the nociceptor. Now, somehow, in fact, when we feel pain, a lot of time is because of it is associated with something like injury, or something is too hot or too cold that it needs our attention. Now, there's some interesting thing about it. These are all through this nerve ending that perceive the so-called pain, and we respond to this because we will have like a withdrawal, and we try to pay attention and try to stay away from it. So in a way, it's helping us to survive. Now, and it is telling us that we get injured and somehow there may be inflammation or so. Now, so this is for that purpose. But remember, when we are sensing temperature, when it's too high, it's hot, it can be damaging. When it's too low, the temperature, it's very cold, it's freezing, it can also be damaging. So therefore, in fact, somehow this perception of pain and the perception of temperature, when it reaches a certain point, they overlap. So what happens is that when the temperature is below 5 degrees or over 50 degrees, in fact, this pain receptor will be activated. In fact, they share something in common in the processing of the neural input. Now, also, we need to think about, well, we need to understand actually how our body is positioned and how we sense something inside our body. So this proprioception is also very important. In fact, it can tell us that what our stationary position is and whether we have any movement. Now, may I ask you to try this out and simply close your eye and see whether you can raise your left hand or raise your right hand, and you can even turn around for 360 degrees. I believe that you can close your eye and you can do all this. Why? Because in our body, we have all this receptor around our body, on our skin, in our muscle, in our bone, that allows us to sense the corresponding position of our body parts, one versus the other, so that we can tell. Now, that becomes important. May I suggest you to do an exercise again. Try to close your mouth. And try to use your tongue. Your tongue can do the same thing. Try to use your tongue and count how many teeth do you have on your upper jaw. Now, you can go one by one, and in fact, you don't see them, but just based on your tongue, you will be able to tell them apart, one tooth after another, and you can count the total number of it. Now, that essentially is a way that what this proprioception is, an ability that we have. We can control our tongue to move around our oral cavity, and it can perform the function to differentiate one tooth versus the other. Now, that is a very important function that we have with our tongue. Now, in fact, when I talk about our tongue and counting our teeth, don't think that our teeth are just used for biting. In fact, you look at our teeth, this, for example, as a representation of a tooth. What you have is that, in fact, the tooth is embedded into our bone of the jaw. And what happens is that between the jawbone and the tooth, there is something we call periodontal ligament, which helps to attach them together. On this particular place, in fact, it is heavily populated by nerves. And what are these nerves sensing? They're trying to sense how the tooth is being pressed on the bone. And so in a way, it's telling us if we bite onto something, how hard is it? Is it a bone? Or is it jelly? Or is it just meat? So that when you bite on it, the pressure exerted on this ligament is going to tell us what's the hardness of the food that we are eating. Now, having all this, essentially I would like you to review it again and say, well, what are the factors that influence our perception of texture? Of course, these, whatever that we put into our mouth, they are made to have certain texture. That's, of course, it's made in the product already. Something outside our oral part is that, well, when we are handling it, for example, when we look at it, we see the visual cues about what the texture is like. We can smell them and see whether they are like a bad smell, it looks like it's rotting. So if it's rotting, then it must be very soft. And when we're handling them, our hand is telling us some information about it. But when it goes into our mouth, in fact, we are masticating it, we are biting on it, telling how hot they are through our teeth. We are sensing the temperature of it. We are sensing how it mixes with our saliva, and then through the sensitivity of our mouth, we'll be able to tell what kind of texture or quality it is. And of course, all this, as I always say in the past, combined with our experience in the past and how they integrate together, whether they are making any consistent sense, that tells us the information about texture. Now, so all this combined together, we call that the mouthfeel. And in fact, when any food that comes into our mouth, the first part that we would perceive the quality of it is through our palate, when we bite on it. So it tells us how hard it is. And then you start to masticate it, you start chopping it into smaller pieces. How fast you can chop it into smaller pieces, and how grainy you feel them, and all this would combine together. And so therefore, a lot of times in the process, we are mixing it with saliva. So if it comes in as like a biscuit or bread, usually they are a little bit dry. Over time, they become softened. But sometimes, for example, if you are biting on a watermelon, when it comes into your mouth, it's already very watery. So that tells you what the quality is. So all this together defines mouthfeel. Having all this, how are we going to elevate the level of satisfaction based on the texture? I'm going to tell you next. In the following experiment, what we want to demonstrate to you is that, in fact, our mouth is very sensitive to size. So we can use our mouth to see what's the size of an object. So the experiment can be done in the following way. We can have some candies, and have the candies, we start cutting them into certain size. In this case, we have one which is only a square, it's 1.5 times 1.5 centimeter. A bigger one, which is 1.7 times 1.7. And the biggest one is 2 centimeter by each side. So what happened, you may notice, is that each of them, in fact, they differ only by 2 millimeter or 3 millimeter, very tiny. This is the way that after the cutting, these candies would look like this. The size is very obvious, but then they only differ by 2 millimeter. So what we're going to do is that we're going to have these candies. We ask the subjects to help us. Again, what we need to do is that simply ask them, well, they close their eye or they have blindfolded, and we provide them directly putting these candies into their mouth, one after another. The first one, the smaller one, and then the medium one, and then the largest one. And after they finish all three, we ask them, can they tell which one is the largest and which one is the smallest? And you'll be surprised that without seeing the size of them, in fact, they can tell which one is larger than the other.
This is the first one, the second one, and the third. So this is the first one, and then remember the size in this case. Okay, and then this is the second one. And then this is the third one, the last one. So after trying all these three pieces, which one do you think is the largest? And you can tell us now.
The last one?
The last one is the largest. How about the smallest?
I think it's the first one.
Okay, the first one. So first one is the smallest, last one is the largest. This is 1, this is 2, and this is 3. This is the first piece of candy. And remember the size of it. Okay, the second one is here. So tell us when you're done. It must be really good. Okay, so here is the third one.
Okay.
Okay, which one is the largest?
I think the third one.
The third one is
Yes. Yeah.
the smallest?
Smallest one I think was first.
The first.
Yeah.
Okay, so thank you for your answer. Here is the first one. Here is the second one. Here is the third one.
The third one is the largest.
I think the last one was the largest.
Third one is the largest one.
Smallest one should be the second one.
The first one was the smallest.
First one is the smallest one.
Going to put it in your mouth, so please open your mouth. You are tasting the first one. Second one. and then remember the size. And then this is the third one, the last one.
The first one is the smallest and the last one is the largest.
Third one was the largest, and then the first one was the smallest.
I think the third one is the largest and the first one is the smallest.
Well, now we get the confirmation. In fact, your mouth can see how a particular food items look like. So in all these tests that we have tried, most of the students, they can find that which one is the larger gum and the other one is smaller. And they can tell the largest and the smallest almost with 100% certainty. In this following experiment, what we're trying to show you is that, in fact, our mouth is very sensitive. It's not only differentiating the size, it's also differentiating the shape. Now, how are we going to do it? What we're going to do is we buy some candies and we cut them into specific shapes such as square, triangle, mushroom shape, or circle. So after the cutting, they will be something like this. Square, triangle, mushroom shape, or circle. And if you want it to be a little bit more challenging, you can also create a semicircle. Now, having that ready, so what we're going to do is you can ask this subject who helped you with the experiment. So simply close his eyes, and then you handed him and directly pass these candies into his mouth and ask him to tell you what exactly the shape is. And if you want it to be a little bit more challenging for them, after they have tasted each candies, ask them to draw it out what the shape is. You'll be surprised that without seeing all these candies what shape they are, a lot of your subjects, in fact, they can draw the shape and tell you what they look like.
Open your mouth and then try to remember the shape and then tell us what is the shape of it. Please open your mouth. Yes, and you can tell us after you have some sense of
The heart shape.
the heart shape. Okay, your answer is the heart shape. Okay, here it is. So remember the shape of it and try to guess what it's like.
This is also the heart shape.
Okay, the second one is also the heart shape. You'll be given a few pieces of sweets, and then we'll give a board to you, and then you need to draw the shape of the sweet. We are getting the first one, and then try to remember the shape. Think about it, and then you need to draw it afterwards. And then the second one is coming up, so please open your mouth and again remember the shape. You can take off your blindfold and then draw it with this. So you're drawing the first one, is it? Yeah. So the second one is. Your answer is the first one is this one. This is triangular shape, and then the second one is like Mickey Mouse. You'll be given a piece of sweet where you need to tell us the shape of it after you have tried. So this time you need to remember the shape.
Okay.
Okay, here it is. Oh, sorry. Okay. You can tell us what is the shape of it. Don't just eat it. Don't remember the shape of it.
Because I think it's a thick rectangular sized candy.
Okay, so the second one is coming up. So please open your mouth. So again, remember the shape. Try to guess like what's the shape, and then tell us.
Interestingly, they're both equally thick.
Equally thick.
But this one is, I think it's a triangle.
It's triangle.
Yeah.
Okay. in this time, and remember the shape. Tell us what is the shape of it.
I think it's a triangle.
Okay, you think it's a triangle. Okay, this is the first piece of candy. So the second piece is coming up, and then what is the shape of this candy?
I think it is a pear shape.
A pear.
Half.
So you mean a pear shape cut into half?
Mm.
The last one. The last candy is coming up. Okay, so this is the last piece. No, and then draw it out the shape. So this is your answer.
Yeah, right.
Can you describe a little bit about this shape?
Maybe like a chair. This is the foot of the chair,
Okay.
and this is the pan of the chair.
The first piece of candies is this one. Please open your mouth and remember the shape. The shape, the shape, the shape. It's all about the shape. What is the shape of it?
I think it was a square.
It's a square. Okay. So this is the second one, and then you can tell us if you have any idea right now.
I think it's a triangle.
It's a triangle. Okay, so this is the last one. After trying this last one, the third piece, so tell us as well as drawing it on a piece of paper we'll give you. So
Okay.
yeah, this is the third one. So right now actually you can take off the blindfold, and then you can draw it draw it here,
Okay.
and then show it
Try.
to the students enrolled. Okay, so this is your answer.
Yep.
Okay, it seems nice. So this time the shape does matter. This is the candy. And then after you have some ideas about it, and you can tell us now.
I'm not sure. It's a long shape.
A long shape. And
Not sure. It's like that.
this is the second piece. So this is the second piece of candy. So remember it, and then draw it out. Draw all the three out later. So this is the third one. Here it is. So this is the third candy. So yeah, you can take off the blindfold, and then you can draw it.
Remember.
First, the second, and the third. Okay, so this is 1, 2, 3. So from her answer, this is the first one, this is the second one, and this is the third one. So this time,
Yeah.
the shape does matter. And now I'm going to put it in your mouth, and you tell us what is the shape of the candy. Okay. So you can tell us now if you have.
It's a square.
It's a square. Okay, thank you. So the second one is coming up, and the second one after you finish the first one. Okay, great. So this is the second one.
This one's like a rectangle.
Rectangle.
Yeah.
Okay. Now this time is a little bit different. Apart from saying out the shape, you need to draw it out. This is the third one. You can take it off by yourself. Yeah. And then you can remember the shape and then draw it. And then you can describe to us a little bit.
So like the first one was a squarish
Okay, show to the-
shape.
Uh-huh.
I don't know if I'm right, but that's what I observed. And the second one was similar. One side was a bit longer than the other, so it was like a rectangular prism, I guess.
Yep.
And the third one, I'm not too sure about this one, but I think it looked like a sort of like a moon kind of shape, like that.
Okay. Okay.
While most of our students, they will be able to differentiate the size of the food item, no matter they are large or small. But then when it comes to shape, in fact, they have more problem. In most of the cases, when the shape is very clear-cut, such as a circle, a triangle, or square, they can tell the difference. But whenever it comes to the point that the shape is a little bit more complicated, such as a mushroom shape, then they have difficulty. So essentially, our tongue and our buccal cavity, they are very sensitive. They will be able to tell large difference. But when it comes to minor differences, they may have problem. And so that tells you what sensitivity our mouth has. So we have just learned about how we can sense the various type of texture. So why is texture so important? And I would like to introduce to you the idea about texture contrast. And texture contrast, in fact, is play a very important role for our determination of the food enjoyment. For example, think about that. Some kind of food that we always eat, chicken nugget. Do you like it? Because of its texture, because of the contrast of the texture. How about some of the brittle candy shell surrounding the chocolates? Well, you like it. Somehow, in fact, we like to have something which gives you one kind of texture, and later on, it gives you another kind of texture to be sensed. For example, something soft, but then suddenly it becomes chewy. All these, essentially, it trying to create a contrast. So this, essentially, comes to the point to look at why certain food are more appealing to us, because they fulfill this kind of contrast generation. And so these, we call it the texture contrast theory. And in fact, when we look at what it is, this tactile experience from the food, to some extent, it push all the way to the level of become like a painful sense, such as we're eating some very spicy food. So it's from texture to all the way to the pain. And combined together, it gives you a very satisfying sensation. Now, so what happened is that when we look at all this texture, some of the ingredients affect how they are being perceived. For example, sometimes if you want to change the texture, you can add a little bit of starch. Starch, depending on what temperature it is, sometimes they can be grainy, sometimes they can be quite mushy. And you can add oil into it, you can add more water into it, and sometimes you want it to be a little bit more viscous. So we add something called the thickeners, so that they become like a little bit more viscous, and more like a solidified. So that gives you the different kind of texture. So all this also have a very important role when we talk about oil, when we talk about water. Think about that. When we talk about aroma, when we talk about taste, taste usually are molecules that would be released into water. And how about oil? A lot of aroma, in fact, they are also soluble in oil. So whether these kind of aroma or flavor molecule, they are soluble in this kind of substances, is also in combination. It's going to generate a combination of senses. Now, with that, in order to change the texture, we can do a lot of things, such as you can homogenize it with a blender. You can bake something so that you can create a very crispy outside but very soft inside. And you can freeze things to make it very hot. Now, so all these affect the structure of the food and influence the way that how we perceive the texture. Putting them together, when we'll say that, sometimes we obviously can sense a lot of different details. For example, when we eat berries, how about the pits? When you eat strawberries, again, all these pits would give you some kind of sensation. Our tongue can tell the number and the size of them. Sometimes when we have, for example, mayonnaise, sometimes we will have ice cream. In fact, our tongue can taste all the tiny particle droplets in all this food. And large particle, it depends on actually what kind of concentration they are. They would be recognized as a separate entity, such as sometimes seeds in the fruits. And all this essentially would give us a sense of how grainy they are, how smooth they are, and that changed the texture. Now, having all that, this theory helps us to understand why we prefer certain food, which give us the maximum of contrast of all this texture. For example, a very good one is ice cream. Think about what ice cream is. In fact, Well, this, when it comes into our mouth, it is going to provoke a variety of system to sense the kind of quality of the ice cream. It goes through all this contrast. Look at that. Ice cream come in, they are frozen, isn't it? Very low temperature. It comes into your mouth. But then it starts to be warmed up. So therefore the temperature constantly changing. How about its viscosity? Originally it's a solid and gradually it gets melted. And so that is converted into a viscous liquid form. And then how about the taste? Usually they are sweet. And how about all the ice cream in it? They are ice crystals. And our tongue can tell the presence of ice crystal. And also, they have a vanilla odor a lot of time. And also, there's oil droplet in it. Originally, they are very tiny one. But over time, gradually they aggregate together to become bigger one. So you are sensing smaller droplets change into a larger droplet from solid, become liquid, and then the temperature from very cold to become very warm. All these changes essentially stimulate our senses, and therefore we like it. And so that's what ice cream is. And so this contrast, texture contrast theory, help to explain why we like it. Why? In fact, this is the purpose. We don't want to be stimulated by the same sense repeatedly again and again. So we want to, in one single bite, we want to experience all the kind of different stimuli. And each one, they're constantly changing so that we would not be simply desensitized for that. Somehow, in the modern days, if you go to an ice cream house, they think that just ice cream is not sufficient. They add fruits into it, they add cookies to it, they add different kind of syrup on top of it to increase the kind of texture that you can sense. Now, it is not just applying to explain why ice cream is like that. When we eat meat, what kind of meat you eat? Well, very expensive Wagyu beef. But when you eat them, do you simply see them as a loaf of meat and then you eat it with a single quality? No. Sometimes you want to have the tendons slightly attached to it. You want to cook it one way or the other so that it has some browning on the surface, so that it's a little bit more crispy, but then inside you want it to be raw. And sometimes when we eat the meat, we want to have the meat with a lot of unsaturated fat. So this is giving you the marbling of all this meat. And we say that, wow, when you take this meat, it almost like instantaneously, it melts inside your mouth. That means it's a change of the texture. Now, more than that, when we drink, in fact, you want to have that kind of texture contrast. Why we want to drink the sparkling water? Because all the air bubble coming out of it, we want to be stimulated by the bubble. And when they come into our mouth, the bubble become bigger, and also they have a different temperature. And so we add all this ingredient in it so that we would be stimulated constantly because of all these features. Think about that expensive food like the foie gras. What you have is that, well, you try to bake it a little bit, and so on the top, again, it's very crispy, brownish, and inside, sometimes they're raw, they're very mushy. When you eat sushi, have you ever go to a Japanese restaurant and you constantly consume the salmon sushi? 10 of it, 20 of it, or 30 of it? You don't. What you do, you go there, you try something with tuna, something with salmon, and sometimes with squid, and you try all different combinations. Why? Because you want your mouth to be stimulated by different kind of meat. And each of them would have a slightly different texture. Some are more tender, some are tougher, and so all this combined together, it maximizes the stimulation. Now, so therefore, with that, I want you to remember, in fact, the experience of eating is a very dynamic process. Dynamic, that's what I want to focus on. And you need to actively participating and use your tongue to sense the kind of texture inside your mouth. And we constantly try to seek the maximized stimulus through the texture and the taste too. Now, so that gives you the rule of thumb why we define it as good food. And think about it. In fact, it makes sense. We are animals, right? So the animal wants to survive. Do you want to constantly consume the same food again and again and again every day? You don't. Because if you do so, you don't have a balanced diet. And yet, if we have the tendency to favor this so-called the contrast maximization, essentially you're trying to taste this kind of food, that kind of food, and you want to try them all. And if each of them represent a different origin or different type of nutrients provided to you through the food, eventually you achieve a balanced diet. So it seems that evolutionarily it makes sense. In the lecture, we have covered the texture contrast theory, telling us that the quality of the food, in fact, will be improved if you have a variety of texture being felt by our buccal cavity. Now, let's do this as an assignment. So basically, what I want you to do is to tell what tastes better. If you are trying ice cream, do you want to try frozen ice cream or do you want to try the melted ice cream? The experiment will be done in the following. It is the most enjoyable assignment that you can experience. You buy some vanilla ice cream, and what you do is that you take some scoop out and put it on a bowl and leave it in the room temperature, allow it to melt so that it becomes a liquid. Put that as one of the sample. And then now you go back to the freezer and take the frozen ice cream out. So you simply want to do two things. One, you first try the frozen vanilla ice cream and make sure you spend maybe a minute or two trying it, tasting it, and enjoy it. And then after you have done that, you can go to the bowl where the melted ice cream is present. And what you do is that you simply put it in your mouth. Essentially, you're drinking it. After you finish both, simply try to think about it. Which one tastes better? And from that, you will understand what I was talking about. Texture contrast theory. The better the contrast, the more the contrast, it tastes better. Well, knowing that, we want to maximize the contrast of texture. Let's look at how we can control the change of the texture. Now, for the food that we eat, usually they are either from plant or from animal. So let's understand actually how the plant and animal they are organized. So here shows two pictures of the plant cells and animal cells. So usually for the animal cells, what they have is just one cell, and they have a very lipid-based membrane and surround them, and that's it. So they don't have anything more. But if you have a plant cell, what they have is that they have like essentially an animal cell, but then they have something called a cell wall that trapped on the outside. And this cell wall, they have some mechanical strength to restrict how this particular cell is going to expand. So therefore, this is the major difference between the two different kinds of cells, animal and plant. So look at what happened. We need to understand that it has a very important implication about diffusion and osmosis in this situation. Why? You recall that when we talk about diffusion, what it is that you have something which is at high concentration at one place and it has low concentration in the other place. So what happens is that the one from the high concentration would gradually diffuse and they move around, and then eventually it moves everywhere so that everywhere would have the same concentration of that kind of molecule. So no longer having any concentration difference. That's called diffusion. So from a concentrated area to become evenly distributed. On the other hand, when we talk about osmosis, usually we're dealing with something called a semi-permeable membrane. Now, so what it is, you think about that, is that if this one is a cell, and this cell has a lipid-based membrane, which is here marked in green. So what you have is that molecules need to move from one place to the other. But this so-called semi-permeable membrane would not allow some of the big molecules to go from one side to the other. So in this case, all these red dots represent those big molecules. So what we have is that, well, with this semi-permeable membrane, on this side you have a lot of these big molecules, they can't go anywhere. But on the other hand, on the other side, you have a lot more water with less big molecules. So in this particular membrane, they will be able to do is to allow the water to move from the side which is having lower concentration into the side which have a higher concentration. And at the end, what it reaches is that a point that both sides essentially would have a similar concentration. And in fact, this concentration somehow is related to a concept called osmotic pressure that makes these two sides essentially have the same osmotic pressure. Then they will stop. Now, that have a consequence, because if that's the case, as illustrated in this diagram, in this animation, what you have is all these water molecules, small one, they will essentially go all into this side, which has high concentration of these big molecules. So what happens is that if this particular big molecule has a cell wall around them, that means they can't go in anymore. And they can't go in anymore, and they keep on trying to go in, so it's pushing them to make it very rigid and very swelled up. And so that's what happened on this side. But think about that. If on this side, all the water goes away, and if there's a cell wall there, so what would happen? All the water goes away, and the cell wall is still there as a rigid thing. So basically, you don't have any water there to support it. So it's kind of become a little bit collapsing. But yet the cell wall is still there. So what would be the net outcome is that with this osmosis, this movement of the water from one region to the other region results in generating some cells which they would have this very swollen property. They're very rigid, they are very firm. Or versus the other side, that when water is taken out, these cells would become flaccid. They are very soft. Now, having that, it has the effect on the plant cell. But how about in case of the animal cell? Animal cell, they don't have the cell wall. So if all this water rush into the animal cell, and this is just a lipid membrane is not very strong, so what happens is that the animal cell is going to burst, right? On the other hand, if this is animal cell, you draw away all the water out of it, so what you have is that the animal cell is going to shrink. So again, it is going to result in a shrunken cell versus a cell that burst. In both cases, the texture, if it's a collective integration of all the cells with such a property, the texture would have been changed. Now, so think about that. How is it going to affect the food? Take for examples like that. When we have prawns, we have a fish or chicken, or sometimes when we put them in the lightly salted water. Now, lightly salted water, that means that there will be more salt outside than inside. So what happens is that the water is going to come out a little bit, but then they don't come out all the way. So what I mean is that some of the water will be drawn out, and in such a case, for example, for the prawn or for the fish, when you cook them, because the water has been drawn out, so that means the protein content inside of the cells are a little bit higher. So when you cook them, when they polymerize at the high heat by the nitration, so they will be able to form some crunchy clumps of all this meat. The same thing when you have the vegetable, again, when you take a little bit out the water out of it, they would still be able to regain this crispiness of the vegetable. But think about that. If I reverse it, instead of using this so-called slightly salted water, I'm simply putting them into tap water. What would happen? Think about that, these prawns. If these are the prawns collected by the sea, they get used to a high salt concentration, so that actually they have a little bit more salt inside than the outside. And you put it in the tap water without any salt. So what's going to happen? These prawns would draw in all the water from the outside, and when the water goes in, remember, these are animal cells. So when water keep on going and going, the cells will keep on expanding and expanding. When they reach a certain point, they simply burst. So what happens is that if you leave them there in the tap water washing for too long, a lot of these animal cells, they're going to burst. And at the end, what I mean is that they are no longer well organized, and so therefore these the prawns turns into a little bit mushy, and we don't like that because we want it to be crunchy. But at the same time, when we deal with some other meat, such as, for example, pork or a beef, when you have the water drawn into it, what happens? If some of the cells are burst, since pork and beef, they are already a little bit quite tough by itself in nature. So bursting a few of those cells, in fact, can make them a little bit more tender. Now, so you need to play around with that and decide that actually how you want to use this osmosis property to change the quality or the texture of all this food. Now, the same thing that when we apply that to the plant, if the water goes in, it just makes the plant more rigid and they're much firmer. Now, having all this, I need to remind you again that basically when we look at any food, we look at the texture. We use our eyes to look at the color, how they shine, how grainy they are, and we look at whether they form lumps, whether they are heterogeneous, and all this is telling us about the texture of the food. And more than that, in fact, human being, we will be able to do a lot of other things. We want to maximize the contrast. So what do? We can use a chopping board. We can chop them into pieces. We can stir them. We can cut them into different shape. In fact, why are we doing it? We are simply trying to maximize the texture, shape, lumber, and all this contrast so that we will be able to enjoy the quality of it. So when it goes into our mouth, we are perceiving the temperature, we are monitoring actually what the size they are. As I said, our tongue is very sensitive. It can tell the very detail of all the things that we take into our mouth. The dentition, using all this sensation of the pressure, biting on something, when we swallow, we're also using our throat to sense actually what kind of quality it is. And all this, when we are trying to masticate all the food inside our mouth, we are also allowing some chemical reaction to go on, because in our saliva, we are constantly digesting some of this food. So therefore, the composition is constantly changing, maximizing the contrast. So as a result, with all this digestion, you may see that, for example, for some of the food, such as the case of like a starch or so, they will be digested and therefore they will change in their viscosity. And all this combined together, it generates variation. And the same thing is that when we eat something into our mouth, our saliva also provides the kind of lubrication. So changing from very dry to be very lubricated. And if something carries, for example, tannin, they would provide the astringency that change the kind of quality or the graininess or the toughness or bitterness of all this food. It makes us feel very satisfying because we are constantly stimulating our oral cavity. Now think about that. I come back to the same idea again. I constantly talk about central nervous systems. We have our memory, we have our emotion. All this come to place because we have our own history. So we remember what kind of food that we like most, we taste in the past. So in a way, cultural experience also make a difference. Think about that. A lot of Japanese food, they are actually quite using a lot of texture, which is quite sticky. People in Japan, they enjoy it because that is part of the kind of food that they have. So we need to think about that again. When we think of a food, whether it's good or bad, in fact, we are really monitoring a collection of all the stimuli, combine it together with our own experience, or maybe sometimes culturally or human history. And only when all of them come together consistently, congruence, if you remember, then we'll find that these are the food which give you the maximum satisfaction. Okay, in this assignment, we are trying to look at actually how we can change the texture of our food. In this case, we are using shrimp or prawns for this particular purpose. So we can try it and see actually how it works. So what we do is that we first purchase some shrimp or prawns from the market. When we get it home, don't do anything with it first. What we need to have is we need to have 2 bowls of tap water, and we have a third bowl which is empty. Now, among these 2 bowls of tap water, what we do is that for this one of it, we put some salt in it. Essentially, it's in the concentration of about 3 grams of table salt into 100 ml of the tap water. When that is ready, we will do the following. We take these shrimps, we separate it into 3 parts. One part goes into this salt water. The other part goes to just the tap water. And the third part, don't do anything and simply leave it in the empty bowl. And what we do is that we leave it there for about 30 minutes. So you can go elsewhere and do something else and come back later. After 30 minutes, what you do is that you take all the shrimps separately, put them in boiling water and cook them, all right? And these essentially, it takes only about a minute or two. They will be all cooked. And afterwards, what you do is that you can take the shrimp out and try to feel how the texture has been changed with your hand. Now, you may be surprised that, in fact, your hand is not very sensitive to it. But then afterwards, you can take it into your mouth and ask, what's the difference? So you first eat the one which is immersed in the tap water and take note of what the texture would be. And then you follow it by eating the one which is not subjected to any kind of treatment. And you ask, what happened? You may notice that there is some difference. And the third one is you take the one which has been immersed in the salt water and you ask how the texture has changed. Now compare them and try to think of a way to explain how come with all these different treatments, they do present to you a different kind of texture. It is the summertime. Nothing is better than having ice cream as one of the food items for our assignment exercise. So in this particular test, we have students trying out ice cream, be it in the frozen form or in the melted form. Out of 6,700 students responding to this assignment, 2% of them, they found that they see both the melted and the frozen form equally good, equally appealing. For the rest, 80% of them, they found that the frozen ice cream actually is more appealing and gives them more satisfaction. While for the rest, 20% of them, they prefer having melted ice cream. Now, in such an exercise, really there's nothing called a right answer or wrong answer, because it's largely depending on what type of ice cream you use, what kind of flavor, whether you like it or not, or whether it is associated with certain experience of an individual. Now, let's look at what the outcome when we analyze it a little bit. For the 2% of the students who found that both the frozen and the melted ice cream, they are equally good. In fact, they ranked them both pretty high at a level of 8 out of a 10-point scale. On the other hand, if you look at the one who said that the frozen ice cream tasted better, the frozen ice cream gave them a score of like 9, and the melted one gave a score of 4.4. The difference seems to be quite dramatic. It's a difference of about 4 point something. Now, when you look at the rest of the group who ranked the melted ice cream to taste better, also it gave a pretty high score, 8.8. But then the frozen one still give you a pretty high score, 6.1, and the difference is only 2 point something. So as a result, it tells you that for a majority in the population, in fact, they prefer having the frozen ice cream, and obviously that is associated with the change of the texture that goes from a very solid form at a low temperature, how it changed to a little bit liquid form at a higher temperature. And the change of the texture certainly play a very important role in this process. So from this point onward, I hope that you recognize that texture and this so-called the texture contrast theory, in fact, is really at work, and ice cream served as a very good example to illustrate these features. In assignment number 7, we're trying to demonstrate how osmosis occurs in animal cells or animal tissue. In this exercise, we ask our students to purchase shrimps from the market and then divide them into 3 portions and put them in different treatment. The first one is immersed into a bowl of tap water for 30 minutes. The second one go into salt water for 30 minutes. And the third portion, which is simply left there, not being dealt with in any specific way. Now, out of 6,200 students responding to this assignment, 1.5% of them, they reported that they did not notice any difference among these three portions, and they either taste equally good or equally bad, and there's no change in terms of the firmness. And I'll come back to that a little bit later. But for 98.5% of the reports, they did notice some difference among this portion. And when we examine what kind of difference they were able to differentiate, they found that in portion A, if you give a score of the firmness, they score 4.2, meaning that actually they're not very firm, or is referred to a little bit mushy, as what we said in the class. For portion B and portion C, the difference is minor. They score 7 or 6.6, and both of them appear to be firmer compared with portion A. Why is that? It is simply because shrimp is animal, and they are made of animal cells with a semi-permeable membrane. So what happens is that when you submerge the shrimp into tap water, the minerals present in the cells, in fact, would be higher than the level of minerals in the tap water. As a result, the water would go through this semi-permeable membrane into the cells, resulting in the swelling and eventually bursting of the animal cells. With this bursting, cells were broken and tissue would be disintegrating. So the net outcome is this portion A treatment result in a more mushy shrimp. Now, having said that, since we have no control how the shrimps were prepared ahead of time or how they were frozen, we know that when we are freezing animal tissue such as shrimp, sometimes crystal and large crystal would form. And when large crystals are formed, they would expand in their size and therefore results in the bursting of the cells. So it depends on how they were frozen. If they're not done properly, these ice crystal, they would burst a lot of the cells, resulting in the breaking of this cell and tissue. So without an intact semi-permeable membrane, putting such a tissue in tap water versus salt water makes very little difference, and they're not going to swell one way or the other. So that may explain why some students find that they don't see any difference, no matter how they treat these shrimp, put it in the salt water or in tap water. And finally, we ask our student to provide a reason why such a change of texture occur. A small portion of the student reported that they choose answer A, suggesting water being drawn out of the animal cells and the cell become flaccid, and so that's why they become mushy. As explained a little bit earlier, if these animal tissue, they are alive with intact self-membrane, the content of the mineral would be higher inside the cell, but not in the tap water. As a result, water would not be drawn out into the tap water. Instead, the tap water would be drawn into the cell. So therefore, answer A cannot be correct. Answer D, the mineral present in the tap water would flow into the shrimp or the animal cells. That again, it could not be right, because we notice that the mineral in fact is at a lower concentration in the tap water than inside the cell. A majority of the students, they chose the answer saying that the solute molecule inside animal cells, they are being drawn out into the tap water. Now, if this tissue is intact with the semi-permeable membrane functioning, solute molecule, they are relatively larger. There's no way they can pass through the semi-permeable membrane and go into the tap water solution. So therefore, the answer C is also incorrect. Eliminating all those, you may now see that why answer B, water being drawn into the animal cells, resulting in the swelling and the bursting of the cell, and eventually lead to the collapse of the tissue. that is the reason why a mushy mouthfeel or the change of the texture occur when you submerge the shrimp in tap water. Now, for this same kind of principle, in fact, a lot of butcher shop or chefs in the restaurants, in order to make the meat a little bit more tender, they would like to soak the meat in tap water for a while. And the reason that they become more tender is by the osmosis or even osmolysis that draw in water into the tissue, which results in bursting of the cells. And because of this bursting, the integrity of the tissue would be damaged, and as a result, they become much tenderer.